Ocean exploration is an initial step for ocean research and is the study of the ocean's surface using concepts from bathymetry, seafloor geomorphology, hydrography, and oceanography. Further discovery of the ocean is crucial, and the development and uses of autonomous underwater vehicles, AUVs, are revolutionizing this research. AUVs are unmanned underwater robots which operate independently of humans, and these generally torpedo-shaped vehicles have transformed the ability to map the ocean. Regardless of the former data collection that spans decades, the evolution of this new technology that implements techniques from old technologies would allow attempts of mapping the ocean to progress greatly. Group 1A members are Emily Williams 816-006-326, Haquifah Woodley 815-007-607, and Nikosi Lessey 816-027-711. In the course of research of this project, I expanded my knowledge on autonomous underwater vehicles, also known as AUVs. I learned how AUVs drastically improved its performance and became more complex throughout the years, from as early as 1957 up until the present day, by adopting new forms and functions. Additionally, I learned about the well-combined architecture of AUV systems. In comparison to the early models of AUVs, which were reliant on onboard software for decision-making, present AUVs utilize wireless communications. Most AUVs also contain processors that were developed based on FPGA and ARM architecture, and they consist of a hybrid system, which incorporates both deliberative and reactive architecture. And AUVs are a progressively relevant tool for ocean exploration, but their usage extends to other industries as well. Lastly, this new knowledge gained has changed my perception of the IT field greatly, as I initially thought that ocean exploration was mainly a combination of engineering, marine science, and oceanography. Now I learn that IT expands throughout the field of ocean exploration along with numerous others, and it is needed in the development of these systems to ensure that the intended task is well performed.
During the course of this project, I was able to gain insights on ocean exploration and the progression of submersible ocean research vehicles. An autonomous underwater vehicle is a marine technology that does not require physical supervision while in the sea and has numerous uses in marine geoscience and is increasingly being deployed in the scientific, military, economic, and policy sectors. An AUV can operate independently of a host vessel, making it ideal for exploring hostile environments such as deep hydrothermal vents and underpolar ice sheets. AUVs have also aided researchers in the discovery of shipwrecks, the collection of significant oceanographic data, the discovery of new natural resources, and have also been used to aid in air crash investigations. Because AUVs are unmanned, they rely on sensors to analyze data and take necessary actions. An AUV is comprised of a functional unit that has a logical and conceptual base. Many components of an AUV's control system have shown to be useful, allowing AUVs to normally advance into superior technology than when it was first developed in 1957. New vehicles and sensors will broaden the spectrum of maritime geoscience applications, while artificial intelligence improvements will boost dependability and flexibility. My perception of the IT field was drastically understated, and by doing this project, I was able to get a better understanding of the many facets of the IT field and the many ways in which IT can be applied.
Throughout the research on this topic, I learned of not only the existence of AUVs, but also of their diverse range of uses. Before conducting this research, autonomy to me was at a basic level, allowing for complex but also simple tasks to be completed with some human monitoring, with machine learning being incapable of handling decision-making for unpredictable events on its own without being pre-programmed to do so. This research not only opened my eyes to the possibility of autonomy in this form of research, but also the complexity and range of things it can handle simultaneously as well. Current AUVs can be set off to conduct missions with zero contact with the researching party that owns the device. Once the mission is completed, AUVs rendezvous at a set location by the researchers, and the data collected can be analyzed. AUVs can achieve longer dive times than human and remotely operated units due to the ARM architecture's low power consumption. It can also reach areas that no human-operated unit can reach due to their larger size, and remotely operated unit due to the cable necessary to control the craft. The architecture, in combination with the programming language utilized, also helps, as any software issues experienced can be fixed on-site. This meant that the researchers would have no need to return to land to have fixes done.